AI cloud security works best as layered guardrails, posture checks, workload defense, SaaS governance, encryption keys, hardware-backed trust, and resilient recovery. In this section, we'll connect those controls into one practical strategy for protecting AI systems in the cloud. We've built upward from identity and access through application and AI security into zero trust networking. Now we add the cloud control plane, posture monitoring, workload protection, CASB, encryption key management, and backup recovery. These controls help turn secure design into continuous assurance for AI systems running in cloud environments. Cloud security is a control stack, not a single product. CSPM provides governance and visibility by finding misconfigurations, exposed services, and risky identities. CWPP protects the compute running models and pipelines. CASB governs SaaS and AI app usage, including shadow tools. KMS and HSM create cryptographic trust around data and keys. Backups provide recovery when prevention fails. The strength comes from integrating these layers, so a gap in one control is covered by another. CSPM keeps cloud risk visible as environments change. It monitors resources such as storage, compute, networks, IAM, logging, databases, and managed AI services. Then it flags issues like public buckets, open security groups, excessive permissions, or disabled audit logs. The key is prioritization. A finding becomes urgent when it affects sensitive data, internet-facing systems, powerful identities, or AI endpoints where exposure could lead to leakage, model theft, or unauthorized use. Modern CSPM becomes especially valuable when it connects separate weaknesses into an attack path. A public endpoint may look low priority by itself, but if it also has an over-permissive role and access to training data, it becomes a serious AI risk. The goal is to find these toxic combinations early. Open ingress, stale accounts, wildcard permissions, and exposed model assets. Remediation can then stay focused, restrict network access, enforce least privilege, and move sensitive services private. At this point, CSPM shifts from reporting problems to driving action. Policies are written as code and tested in the pipeline, so insecure infrastructure can be blocked before deployment. When findings still appear, automation can handle routine fixes, turn on encryption, block public access, enforce logging, and verify the result. Higher risk exceptions should follow a formal path, with approvals, expiration dates, compensating controls, tickets, and SIM or SOAR visibility. CSPM checks whether the environment is set up safely. CWPP asks a different question. What are workloads doing right now? It watches VMs, containers, Kubernetes, serverless functions, and GPU-backed AI nodes for process activity, file changes, network connections, vulnerable packages, and suspicious behavior. That runtime view helps catch crypto mining, reverse shells, container escapes, credential theft, and attacks against model-serving systems before they become larger incidents. Platforms rarely run in one place. Training may use GPU-backed virtual machines, inference may run in containers, orchestration may sit in Kubernetes, and event handling may use serverless functions. CWPP gives teams a common protection layer across those patterns. The checks vary by runtime: host activity and file integrity for VMs, image drift and privileges for containers, pod and cluster risk for Kubernetes, and permissions, triggers, dependencies, and secrets for serverless. Consider a compromised inference container trying to copy model weights out of the cluster. That GPU node is not just compute. It may contain models, data, credentials, and costly resources. A CWPP watches for runtime signals such as unusual processes, unexpected egress, unauthorized containers, and GPU abuse. When behavior deviates, it can alert, block access, and help isolate the workload into a hardened node pool. From there, teams preserve evidence, inspect artifacts, and confirm whether data or models were touched. A CASB acts as a control point between your workforce and the cloud services they use. For AI governance, this matters because risk often appears outside approved channels: pasted data, shadow AI tools, risky OAuth grants, or unmanaged plugins. The CASB discovers those services, monitors activity, and applies policy based on data sensitivity, device trust, location, and user risk. The goal is not to block all AI. It is to make approved AI usable while reducing uncontrolled exposure. In practice, the CASB becomes a decision point between users and cloud apps. When someone uploads data, it can inspect the content for code, customer records, credentials, regulated data, prompts, or AI outputs. It then checks the application's risk and the user's context. The response might be allow, warn, and coach, encrypt, quarantine, redact, require stronger authentication, or block the action. Just as important, every decision is logged for governance, privacy, and compliance evidence. KMS is the control plane for encryption keys. Instead of every AI service storing its own secrets, workloads ask KMS to create, protect, rotate, and authorize key use. Envelope encryption keeps this scalable. Data is encrypted with short-lived data keys, while master keys stay protected inside KMS. This gives you centralized policy, IAM integration, tenant and regional isolation, and audit logs showing who used which key, when, and for what. In short, KMS turns encryption into an observable governed system. For the highest risk AI systems, key management may need hardware-backed assurance. An HSM keeps cryptographic keys inside certified tamper-resistant hardware, making them harder to extract even if software or admin access is compromised. This supports customer-managed keys, bring your own key, hold your own key, signing, and high-assurance encryption. The trade-off is higher cost and operational complexity, but with stronger custody, compliance evidence, and separation of duties for regulated, sovereign, or high-value AI workloads. Backups should be treated as a core security control for AI, not an afterthought. Protect copies with KMS or HSM-backed encryption, tight access control, and separate audit logs. Make them versioned, immutable, and logically isolated so ransomware, mistakes, or insider misuse cannot erase recovery options. Coverage must include datasets, feature stores, vector databases, model artifacts, secrets metadata, logs, and pipelines. Finally, prove recoverability with tested RPOs, RTOs, model rollback, dataset restore, and infrastructure recovery. Cloud security depends on durable controls working together. CSPM for posture, CWPP for running workloads, CASB for SaaS and AI governance, and KMS, HSM, and backups for trust and recovery. Together, they create the baseline needed to secure Kubernetes, AI workloads, and multi-cloud patterns with confidence.